Right, now let's go on to discuss problem number 3 here. We're given some percent mass composition data, and from that we will determine the empirical formula for this particular compound. And one way that we can make this solution much easier to understand is to assume that we have a 100-gram sample. So what's true for a compound is, regardless of the size, whether it be 1 gram, whether it be 1,000 kilograms, if it's a pure compound, the percentages are going to stay the same. So by assuming that it's 100 grams, in a 100-gram sample, there would be 55.78 grams of carbon, 11.70 grams of hydrogen, and 32.52 grams of nitrogen. Okay, and now I have something that I can get my hooks into, but because I can use the molar mass from the periodic table in order to convert grams into moles, and then go about getting the mole ratio for the empirical formula. So I'm going to start out element, and I like to organize this in a table. And then I'm just going to write what we had up there: 55.78, 11.70, and 32.52. I'm going to remind myself that this column is mass in grams. Next, I'm going to have the molar mass in grams per mole. This is simply the decimal number that's from the periodic table. And these I use so often I know them. So 12.01 for carbon, 1.008 for hydrogen, and 14.01 for nitrogen. Okay, now with that all organized, we've got grams per mole. If I divide the numbers in this column by the numbers in this column, it'll give me moles. So I'm going to do 55.78 divided by 12.01, 4.644, 11.70 divided by 1.008, 11.61, and 3252 divided by 1401, 2.321. Okay, now we have something. This respects the mass ratio, but now we're in moles, but we're not quite there yet. And the common mistake is you don't want to round these off. What you want to do is, while respecting this mole ratio, try to get something that's closer to an integer. And what I'm going to do is I'm going to divide all of them by the smallest. Okay, so the bottom one here is easy. It's any number divided by itself gives us 1. The top one, 4.644 divided by 2.321, is very close to 2. And the next one, 11.61 divided by 2.321, is very close to 5. So this is our mole ratio that we have here. Okay, so this empirical formula is C2H5N.